Hello and welcome to this most wonderful time of the year. The Advent of Code is here. If you don't know what is Advent of Code, it's an advent calendar of small programming riddles that open up every day for 12 days in December. This is a great opportunity to scratch your head and solve different riddles that you would otherwise not even encounter in your day-to-day job. So join the fun and go and solve these problems on your own, and then come back and let's compare our solutions. If you're interested more how it works, watch day 1, but today we are proceeding with day 6. After helping elves in the kitchen, you were taking a break and helping them to reenact a movie scene, where you over-enthusiastically jumped into the garbage chute. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door is being magnetically sealed. As you try to find a way out, you are approached by a family of cephalopods. They're pretty sure that you can get the door open, but it will take some time. While you wait, they're curious if you can help the youngest cephalopods with her math homework. Cephalopod math doesn't look that different from normal math. The marked worksheet, your puzzle input, consists of lists of problems where each problem has a group of numbers that needs to be either added or multiplied together. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, here is the sample input. Each problem's numbers are arranged vertically. At the bottom of the problem is the symbol of the operation that needs to be performed. Problems are separated by a full column of only spaces. The left and right alignments of numbers within each problem can be ignored. So we have columns of numbers, and at the end there is an operation. So the worksheet contains 4 problems, so 4 columns, and we need basically to either multiply them all together or sum the column together. To check their work, cephalopod students are given a grand total of adding together all of the answers to the individual problems. In this worksheet, the grand total is this number. Of course, the actual worksheet is much wider, but you will need to make sure to unroll it completely so that you can read the problem clearly. So solve the problems and find a total number. So initially it sounds pretty straightforward. Looks like we just need to correctly load it and parse it. So as always, I will create some sort of helper functions. One will be to extract the operations, and we will provide an input, basically the last line, and we are interested in returning an array of these operations so we know what to perform. And one of the great things in Go that actually there is already function for it. So we can use function string fields, which will just split the strings around each instance of one or more consecutive white space characters. That's exactly what we need. They are separated by white space characters, we just need to extract them. So on the part 1, here we would start that we want to have our operations, and which would be the last line of the input. It would also mean that there would be that much results as operations, and we at the end need to sum it into some sort of total and just add everything together and return back the total. So now here is the middle part that we need to process. And each position would be some sort of value that we slowly either add up with some other values or multiply by some number. So technically it should not be really empty initially, but be the values of the first line. And I think we could just parse line by line and go then operation by operation and accumulate the result. So here for the function get operations, I will also create function get numbers, which would be the same way, except here we will just return integers, which we could solve similarly, starting by strings that we try to get the fields first from the input, and input here is just a line. And then we want to transform them into a numbers, string conversions, and return the numbers back. So here can be an error, so we need first to get the number, then the potential error that we ignore, and add it here, just like that. Here, instead of results, we can say that the initial result would be the numbers that are located in the first line. And then starting from first line till how many we have in our input, -1, because we don't want to process the operations line. We get the numbers, and then we go over each operation and switch. If the operation is plus, we add the value to the existing result. If it's multiplication, then we multiply it to existing. And then, yeah, at the end, we just sum the total and return back. So looks simple enough. So let's test it on sample input of the problem. So this was given sample input and we expect to get at the end this kind of number. So let's quickly compare if it is like that. And yes, the sample input provides the correct result. How about the puzzle input itself? So let's read the input file, which is my puzzle input. Then we split those lines and pass it to the part 1. Based on my input, this should match this number, which I have solved previously, but you will have some difference, so initially you will not know it. You will need to put it into a problem. We can test it out and see if it worked out. So 3, 2, 1, and hooray, we have solved part 1 and earned our first star of the day. Let's go to the part 2. That's usually where things get tricky. The big cephalopods come back to check on how things are going. When they see that your grand total doesn't match the one expected by their worksheet, they realize they forgot to explain how to read cephalopod math. Cephalopod math is written right to left in columns. Each number is given in its own column with the most significant digit at the top and the least significant digit at the bottom. Problems are still separated with the columns consisting only of spaces, and the symbol at the bottom of the problem is still the operator to use. Here is an example worksheet again. So reading the problem right to left, one column at a time, the problems are quite different. So 4 plus 4, 431, 623. So this is the rightmost problem. So it's per column. So 623 plus 431 and plus 4. So that would be clear. And here would be the 175, 581 and 32. And you can see actually that white spaces here matter because they are positioning where are the significant digits. So it's basically saying which digits are here, right? So here it's 8, in this case here it's 1. So we need to save those spaces. Okay, and again, after everything, we need to find the grand total and return back, in my case, which is this number. Okay, so now things actually are harder because we need to parse the numbers now not by the row, we need the whole column and then each digit itself. I would say we need to start and break this problem down into smaller manageable steps because right now, immediately I don't think that it's quite straightforward to do. Anyway, it will start similarly. We need to find our operations, where we can reuse our getOperations function. We know that the results will be the same number as the operations, but now we cannot assume that the first numbers will be just here zeros. Let's make an empty integer array with length of operations, because that's how many results there will be. So then here I will actually define function sum, and I will pass values of integer, because we will need to do the same thing that we already did here. Just in the first place, replace return sum of the results. And here as well, there will be just sum of the results. And here I think the first step would be to get the grid itself of numbers. I guess technically it would be better if we could get the two-dimensional array of all of those string values and then we slowly process them, because then it would be easier to iterate through columns because we cannot now parse it by rows. So I will define a function get value grid, which will be initially this string, but I will want to have strings because we need to persist the spacing. And while go ahead is great functioning fields, the problem is that it will take one or more consecutive white spaces. Here ideally would be something that could split just by the space, but we can see that there are multiple places where it could happen. Right, so there are multiple places where it could happen. There could be in the middle many spaces. But if we look closely, we can see that operations could be the one teller for us. So it always starts with the first digit, and then next one also starts with it. So we could technically try to find indexes of these values, and then take substrings till the one digit before. The one character before. Okay, in the result we will get the grid of the same row amount, except the last line actually is not, because we are not interested in operations. And now it would be great if you could find all of the indexes of non-white space characters in the last line. So if this is operations line, would be this last one. We are not interested in getting operations, but we are interested in finding indexes of all elements. For this, we could use regex actually. So we could take a pattern, regex must compile, and I want to find either the plus or the multiplication symbol. While they are regex characters, we need to escape them. And this is an OR condition. We could technically call it sizes, and we could find our string index on this operation line, which should return from where to where it started to match. So maybe let me print that out, the sizes. And here at the end, we will return the grid. Again, we need to call it somewhere here. For example, grid is equal to get values grid. And it is not used. Let's just output something. Then here, the part 2 on the sample input, you can see here. So here are matches from which character to which. So from 0 to 1, it's the first match. Then from 4 to 5, so 0, 1, 2, 3, 4. Yes, the next one will be at 8. So this was 4, 5, 6, 7, 8. And this is at 12. 8, 9, 10, 11, 12. So we have found all of these indexes. So basically we need to just take the strings from one index to another minus 1. Here I can go through each of the lines except the last one because I'm not interested in the operations. Okay, here, so we take the line and then we need to create a row in this input, which will be an array of strings, one row array of strings with length of sizes or lengths of the operations, right? It's just lengths of the sizes. And now we need to go over these sizes and extract the length from the previous. So we can start with the next one. We go while it's less than sizes j plus 1. Then the start would be the previous size start. So we are taking the number from the start, and end would be of the current size start of these pattern indexes that we found. And then technically we could put in the grid at the position ij minus 1. So in the previous one, because we are taking the next one and the previous, and then taking like backwards the value. And we are taking the substring from this line, starting from start till end. And then we are actually not using this row. We could directly say grid I equals this make. Looks good. Okay, let's go and run the test and see how our array looks like. So, 1, 2, 3. Then there is space and one more space. 4, 5 at the start there is this space. 6, 4 there should not be a space. Okay, how many spaces does it use for delimiting? Looks like we are taking one additional, because we need to here take the end minus 1. We need to not go to the next symbol. Okay, 1, 2, 3, yes, separated. 3 to 8, all okay. One space before the 51. And should be one space after the 64, yes. And we're missing last number. Because at the last step we need to take from last start position till the end. Length sizes, Then we want to take from lines, the sizes last one, the last sizes, start, and we want to take it till the end. So now it could be correct and looks like it is. So we have successfully extracted values with their spacings. So basically we have prepared our input data. And now I think we are going to the second hardest part. Now mapping those column numbers into an array of integers. So let's create a function for that. And I will call it cephalopod math to int. Let's call it like that. So first of all, I would create these ints. which would tell how many numbers we will get, but we will not have how many rows there are, but how many columns instead. So how large is the first string? And okay, then we want to go line by line. So it is our number, which we'll need to split into our digits. So we're now basically going this number, then this number, and this number. So this would be the first digit, and add to it all the first digits that would be below it. Same goes that then when we go to the second digit, then we will need to add all the second digits together. Of course, if it's not space. So if you're currently looking at the number, we need a place where we would store those numbers initially. So there would be empty strings by default, and then we go over each character. And if the character is not space, then we append it to this strings number. And I think that's actually all. The only last step is to go over these strings, convert them into integers, thanks AI, and return back the ints. And that would be the cephalopod math. So I want to test it out. So let's create a test for it. Let's take some sort of sample input on which we want to test, which we can actually make it be take from this example. So then the 64 space and 98. Okay, let's start with this one first. So then the expected result would be an integer array of values 369, then 248, and just 8. And we would need to compare the results. Let's run it. And success! So we have successfully transformed it into our correct result. So looks like we are on the right track. So now we have here the grid. We will need to go over each column and collect all the results, because that's how we actually implemented it. So for call each, which is 0, and we need to go, which should be the length of operations. Yes, that's how many columns there are. Then we need to collect our numbers into this string and go over each grid just like that, and then get the ints using this cephalopod map. So we need to collect the column first and then pass it into the function and get our integers back based by the cephalopod map. And now technically based by operation we need to do the one thing or another. So I will just create one more function. Here we had sum. We could also have multiply, where we start with 1, which would not be correct, where we should start with the first value, then start from the first till end, and each multiply together. Yes, we technically could use 1, but if the array is empty, the result should not be 1. And then here it means based by the operation. If it's plus, we want to result sum. If it's multiplied, then we multiply, and at the end we sum all the results. Looks kind of compact and beautiful. Let's hope that it works. So let's run the part 2 on the sample input, and the sample input is okay. Then the big question, will the puzzle input work now? So 3, 2, 1. Success! We have solved part 2 and earned our second star of the day. Day 6 was trickier than the previous days, and I really like that. I hope the further days are also interesting. Did you come up with any better solutions? Maybe there are more optimal ones? Let me know down in the comments. Once again, I will repeat myself, go and solve the next day on your own, and then come back and let's compare the solutions. Because I think that's the most fun part, is to actually trying to solve it, throwing your problem solving skills into the action. If you enjoyed this content, leave a like, subscribe. I'm almost at 200 subscribers. I really appreciate your help. But other than that, keep coding, and I see you tomorrow.